Have you ever stopped to think about how your phone just gets what you're saying, or how a search engine finishes your thoughts? Well, today, we're going to pull back the curtain on the magic behind it all. We're diving deep into natural language processing, or NLP, the incredible mind-bending science of teaching machines our language. All right, so here's our game plan. We're going to start with the sci-fi dream of talking machines, then get into the real nuts and bolts of how computers actually learn to read. After that, we'll hit the deep learning revolution, tackle some of the serious ethical stuff, and finally, take a peek at what the future might hold for all of us. So let's kick things off with an idea that has been bouncing around in our collective imagination for, well, almost a century now. This dream of having a real, genuine conversation with a machine. You know, this very question, this was the kind of thing the legendary Alan Turing was thinking about way back in 1950. For him, it was a benchmark for true intelligence. And what's wild is that what was once just a theoretical idea, something you'd see in the movies, has totally jumped off the screen and right into our pockets. The truth is, you are using natural language processing all the time, probably without even noticing it. I mean, every time you ask Siri for the weather, or Google finishes your sentence, or you argue with a customer service chatbot, yep, that's NLP in action. It's this invisible engine that's running a huge part of our digital lives. So how in the world do we actually get a machine to understand something as messy and human as text? Well, it's definitely not magic. It's more like a super meticulous process, almost like a digital assembly line for words. So let's break down how that line works. At its very heart, NLP is all about building a bridge between our complicated, nuanced, sometimes illogical human language and the super rigid black and white world of computers. It's this amazing mix of computer science, AI, and linguistics all rolled into one. Think about it like a chef prepping ingredients for a big meal. You can't just throw everything in the pot. First, you take the raw text and chop it up into individual words or sentences. That's tokenization. Then, you toss out the boring stuff, the common words like the, and, or a, that don't add much flavor. That's stop word removal. Next, you simplify your ingredients, reducing words to their core meaning. So running and ran both just become run. That's stemming. And finally, the most important step, you have to turn all those words into numbers, because numbers are the only language a computer really understands. That's feature extraction, and only then can the model start its training. Now, this slide shows a huge shift in how we even thought about this problem. The old school approach from guys like the famous linguist Noam Chomsky was to try and write down every single rule of grammar. But that's kind of like trying to teach someone to swim by giving them a physics textbook. It's technically correct, but totally useless in a real messy ocean. The modern way? It's all about statistics. We realized it's way, way more effective to just throw the computer into the deep end of the internet and let it figure out the patterns for itself. And that massive shift, this idea of learning from data instead of being programmed with rules, that's what set the stage for one of the biggest explosions in the entire history of AI. And boom, in 2017, a paper introduced a new architecture called the transformer, and it literally changed everything. Its secret sauce was something called an attention mechanism. It let the model look at an entire sentence at once and figure out which words were the most important to each other, no matter how far apart they were. Suddenly, computers could understand context on a whole new level. This is the tech behind all the big names you hear about today. Google's BERT, OpenAI's GPT series, you name it. They're all built on this transformer idea. You feed them a gigantic chunk of the internet, and they get incredibly good at one simple thing, predicting the next word. But by doing that, they learn to do so much more, understand nuance, context, and even generate text that is shockingly human. Okay, but here is the massive critical catch. These incredibly powerful models, they learn from data created by us. And that means they're learning from all of our collective genius, our creativity, and our brilliance, but they're also learning all of our flaws, our prejudices, and our biases. And that brings us to what is, without a doubt, the most important and difficult challenge facing this technology today. We have to talk about the social and ethical side effects of creating machines that learn from us. Just take a look at this. This is such a stark visual gut punch. A few years ago, if you searched for images of a homemaker, this is what you got: an ocean of women. Now, the AI didn't invent this stereotype. It just perfectly mirrored the data it was trained on, all the ways we as a society had labeled and talked about this role online. And here's the other side of that exact same coin. A search for CEO from the same time? It's a wall of men, mostly white men. Again, the model isn't being malicious here. It's just a pattern-matching machine. But by reflecting the patterns it sees, it ends up reinforcing this really narrow and, frankly, inaccurate view of the world.
And look, this problem goes way beyond just biased images. We are grappling with enormous challenges, like models being used to create fake news, the very real threat to our privacy, and the fact that these incredible systems often just don't work as well for people who speak minority languages or dialects.
You don't have to take my word for it. Researchers at Stanford put it perfectly. These biases aren't just little bugs to be fixed. They are pervasive and pernicious. They are everywhere, and they are incredibly harmful. Okay, so that's a lot of heavy stuff. But it is not all doom and gloom. Not by a long shot. Because even with all these challenges, the potential for this technology to do some real good in the world is just immense, as long as we go into it with our eyes wide open. I mean, just look at healthcare. NLP is already being used to scan millions of patient records to find people who might be at risk. It's analyzing social media to spot the next pandemic before it starts. It's even helping break down language barriers between doctors and patients. This is a seriously powerful tool for good. So when you boil it all down, NLP isn't some alien intelligence that's come to visit. It's a mirror. It just reflects back at us everything that we are. The vast, the complex, the brilliant, and yeah, the biased parts of who we are. The real challenge and the opportunity is deciding what we do when we see that reflection. Which leaves us with this one final massive question to chew on. As these AI systems get better and better at speaking our language, who is ultimately responsible for what they say? Who's on the hook for their words, their biases, and their impact on our world?